Hi everyone, this is Prithvi Prabhu, UR16CS309. I'm here to explain about multi-threading, synchronization, and inter-thread communication with a sample program. Multi-threading. Multi-threading is a process in which we can concurrently execute two programs at a time. Like we can say an addition and multiplication at the same time with for two different numbers. We can execute it at the same time, and for that we need multi-threading, that is two processes running concurrently. And synchronization is for normally if you do multi-threading, it takes the time of for each process. Like for addition, if it takes 0.3 seconds, and for multiplication 0.5 seconds, automatically additions will go on doing, like go on adding before even multiplication could do, like in like 0.15 seconds, 5 of addition program will be done, whereas multiplication will be only 3. So to avoid that, we are using a process called synchronization, in which first the specific addition will be cleared and then multiplication will be touched. Until then, everything, two of these threads, first thread is for addition and second thread is for multiplication, both will wait. And inter-thread communication is about we need to, since because these are addition and multiplication, it doesn't matter, but if both these multiplication and addition use the same number as a common input, we need this inter-thread communication. It is more like the lock and key. Like first thread, it will get the input and it will come out. It lets the other thread to go in and use the same input, and it comes out, and like that one thread and the other will help each other simultaneously. They'll share their data with each other with lock and key, like notify and wait as we use here. So let's see how it works. I've created a program here that is a linked list with the help of threading. So let's see how it works. Even though we have default methods for linked list, I'm using the original type, and this is a class node, as you can see, in which these are all structures, and this is the data which we are going to feed to the node. This is a pointer, as we can see in C++ we used as a pointer, but here we are using the same class name, and we are creating a head node to show that it is the starting of the list, and this is for any new nodes. We are going to use it further in the program. This is an empty constructor, and this is a constructor in which the data which we get from the user gets stored as data next here. As you can see here, this is a method for creating a new node. This thing automatically actually it gets the input, and it should create a node. So for that we are using this new node. When we pass the data, then pointer and the data we are getting it from it, and the pointer, since because it is a new node, it doesn't have any next node or something, so it is null. So when we pass these two as the arguments, it creates a new node with the data as we give and the null as pointer. See, we can see synchronized, and over here also this is for adding node, and here we can see synchronize because one process will do and it will wait for the first process to finish, then only the second process will start, even when if it has less number of executing time. So synchronize is used, and as you can see here, once it is the node is created, it notifies the other one to use the data, the shared data, that is the value of the node. And once it is done, it will go to wait. It will notify the other node and it will wait till the other node finishes off, and next it will continue its process again. And here add node, this is to add the present node to the end of the linked list, and if it is null, the linked list is null, it will add in the first position, and if it is not, the next position the created node will be added. For that we are using these things. And here also, once this method finishes off, it notifies the create node and it waits till its turn comes. Both these places, when the data is created and data is added, these outputs will come. And as you can see, I'm using two threads. This is for creating a thread, creating a node, and this is for adding node. Here we create a main thread which extends the thread class, the other class, and it is usually having many number of methods. And here if you extend like runnable, it will be only for run method, but still because we are using thread, we can create constructors also. I'm using constructor, and I'm getting the value stored here, and then from this we can pass the value to the node class. And in the run method, I'm getting the input from the user and I'm sending it to the create node. Same goes here, but I won't get the input, but instead I will use the shared data that is already in the created node. Data will be that will be shared to the add node over here. This is the main method. Here I am creating object for every node, and we have to start the node, otherwise the thread won't work. So I am starting it here, and I have created some objects also. So first creating the thread, and we are going to give the input, and once we give the input, it will go to the thread. It will call the create node and add node, and the data which we give will be added in the nodes data and also in the linked list node. So let's see how it works. So now let's add some data in the linked list. First I'm giving 5. So once I give the 5, it will first create node and then it will add node. So it is created and then added also. It's taking time now because I've put some time for the sleep. So after some time it gets created and gets added. And now I'm giving another data. See, it takes some time, but if we give it soon. It will take some time. Let's see, it is taking time because it takes some time. It is in sleep mode, and then it will be created and added. So this is how it works, and thank you.